we have a high pass filter here, and its maximum gain is not unity. At infinitely large frequencies, this gain is designated by a voltage divider between these two resistors. Our task is to find the cutoff frequency and the gain at this frequency, both a dB gain and gain in linear scale. Obviously, this is a very simple task, and we may find these values algebraically from these formulas. We may find the cutoff frequency to 55 Hertz. At this frequency, minus 14 dB is the gain in dB scale, and this is 0.14 volt per volt linear scale gain. Or we may find these two values, three values, using PSpice. At first, let me show you a screenshot. So we have the gain, actually output voltage as input voltage is unity. Gain in dB scale at first, and for this gain in dB scale we are looking at first for a cutoff frequency, then we are looking for the level which is maximum minus 3 dB, and for this level we have 255 Hertz. It is our cutoff frequency, and we may obviously read that for this frequency dB gain is minus 17 dB. Then we may move to a lower plot, which is at the same gain but in linear scale, and we may read that this gain is 250 Hertz is around 0.14 volt per volt. Okay, now let me show you how to operate, how to create these two plots, how to operate a probe window. Okay, now we are in PSpice. The netlist has been stored already. Now we have to run a simulation, and we have to add a trace. So at first, let me add a dB gain, which is 20 multiplied by logarithm of V2. Okay, so this is the dB gain of our filter, and we are looking for the level maximum minus 3, which means at first we have to toggle cursor, then search forward, level, and maximum minus 3. And we may read the cutoff frequency. For this level, the gain is minus 17, and the cutoff frequency is 255 Hertz. To find the gain in linear scale, we have to add another plot to this window. We have to add another plot to this window, and this plot is gain in linear scale. Okay, so we have the same gain in dB scale and a linear scale. To read this value, we have to click on the upper plot, and we may read this is 141 millivolt per volt, which confirms our calculations and completes this exemplary problem.